8.4 Equations of sinusoidal functions. The form of a sinusoidal equation often will follow the format of y equals a sine b bracket x minus c plus d, or the other option is cosine, so y equals a cos b bracket x minus c plus d. Now, a is always going to be the amplitude. Okay, so when we're talking about our sinusoidal curve, and this is the axis, the equation of the midline, the amplitude is here, or the amplitude is here. B will always equal 360 degrees divided by the period, or if we're dealing in radians, 2 times pi divided by the period. Now here's a funny thing with this. If you do some fancy algebra, if you want to figure out what the period is, you're going to say the period equals 360 over that b value that you're given in the equation. Or, if it's in radians, 2 pi divided by b. This is more likely going to be the question. Given this equation, what is the period? So you will have to remember that, the period is just 360 or 2 pi, depending if you're in degrees or if you're in radians, divided by that b value. C is the horizontal translation. Okay, that's how much it goes to the right or to the left. And D is the equation of the midline. How nice is that? So y equals that D value. Now if D is negative, then your equation of the midline is going to equal negative value. But oftentimes people are going to mess up this in the bracket, minus c and then plus d. Remember, the d is all in its lonesome, not inside a bracket. Let's look at example 1. Consider the function y equals 2 cos 4x plus 1, and we're noticing here for the interval between 0 and 360. Notice to identify that this is in degrees. So when we verify it with our graphing calculator, what we're going to do is we're going to make sure that it's set to degrees. I also just want to remind us of the different format. So y equals a cos b x minus c plus d, where a is our amplitude, b helps us figure out what our period is, c helps us to understand how much it's shifted left or right, and d tells us the equation of the midline, or how much it's translated up or down. So describe the graph of the function by stating the amplitude, the equation of the midline, the range, the period, as well as any relevant horizontal translation of cos x. Then B, verify using graphing technology, which we will, wrong button, which we will do. Ta-da! So, first things first, let's get to A. The easiest thing to do is to identify what our amplitude is. That's our A value. So I'm just going to say my amplitude is 2. Why? Because that's what the A value is, 2. The equation of the midline is the second easiest. And the only reason why it's a little bit more difficult is you have to remember that you have to state in terms of y equals. Y equals our D value, which is positive 1. I'm just going to highlight all this in pink. Now, the common mistake that people make is that they confuse C with D. But we'll get to that when we talk about the horizontal translation. Next, we want to figure out what our period is. And if we want to go back here, I should do this. The period actually equals, and I gave you an equation for that. The period actually equals 360, oh sorry, this one right here, 360 over b, or 2 pi over b. And since we're working in degrees, we're going to use this one. So period equals 360 over b. Now in this case, our b is going to be 4. So that equals 360 over 4. Just going to show you where I got that. And that means our period is 90 degrees. So that means that every 90 degrees we're having a reoccurring pattern. So this, well actually that's a sine curve. Boop. Okay, that's 90 degrees. Boop. That's 90 degrees. Boop. That's 90 degrees. Okay, so every single time the shape recurs, it's 90 degrees. Last but not least, oh, the thing that I forgot here was after the range I wanted to do the midline. Oh, sorry, after the midline I wanted to do the range. So the range, we have to have a maximum and a minimum, and we calculate our max by saying d plus the amplitude. Because if I were to draw this thing sinusoidal, this right here is the midline, that's y equals 1. But we have an amplitude of 2. So that means that the maximum occurs at d plus a, 1 plus 2. So 1 plus 2 is 3. And the minimum, we're saying that our equation of the midline minus 2 is going to be negative 1. So the minimum occurs at d minus a, which is 1 minus 2, which is negative 1. So if I were to state my range, it would be negative 1 is less than or equal to y is less than or equal to 3. Y is an element of the reals. Last but not least, I want to talk about our c. You'll notice that if we compare here our minus c here, oftentimes people will confuse the c with the d. Just remember the c is going to be the thing that's in brackets. Now, the thing that's in brackets here is 0. X plus 0 or x minus 0. So there's literally nothing I can highlight here because the c just isn't there. So then what we can say about our horizontal translation, so that means moving from right to left, there is none. So when I graph this thing, I'm going to go into my my functions, and I'm going to hit cancel, and I'm just going to type in this exact formula here. Boop, 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 boop. So I'm going to say y equals 2 cosine of 4x. Oh. Now it automatically pops up and puts a bracket there. You can do a double bracket when we need to. Plus 1. I'm going to graph it. I'm going to change my window settings, and I'm going to make sure that I'm in degrees here. So I'm going to go mode. I am in degrees. Very good. So second, okay, I'm going to go back here, and I'm going to go back here, and I'm going to go to my window settings here. So that's all good, but I don't want to just go to 2 because I know that I'm going above 2, so I'm going to go to 5. Let's see what this looks like. There we go. So there are a few things that we can check here. We can see that the amplitude is 2 because I go 1, 2, 3, 4. The whole height of it, okay, is going to be 4, and half of that is going to be 2. I can see just from here that the equation of the midline is 1. Great. And I can see that I go from negative 1 to positive 3. Great. Now the other thing that I want to verify is the period. So we said here, according to math, we calculated it that it was 90 degrees. But let's indeed see if that is true. So remember how we calculate the period max to max, min to min, or max to min times 2? So I'm just gonna go from max to max and see. So I'm just gonna go like that. Yeah, enter. Enter, enter. So my maximum in the x direction, remember what I said, like e to the -6, don't worry, this is just 0, okay, because it's very, very, very small. So the first maximum happens when x equals 0. When is the next maximum? Second trace. Maximum. Come on, buddy. Enter. Enter, enter. The second maximum happens at, it happens at 90. So that means that the pattern repeats after 90 degrees. Look at what math told us. Math told us the same stinking thing. So that is absolutely fabulous.